Okay guys, so this is the class problem that we did on that ethanol example, and there's some real important information in this one example. So we're going to take it slow, we're going to use our emojis, and we want to get to understand as to what is really happening in this whole batch fermentation. So let's get on with it. So this is what you have here is a plot directly from the example. This is where I plot mu and theta against time. I'm just going to take the exact same graph and draw it on a green background, so it's roughly the same. That will just make my emoji placement a bit easier. So what's happening over here? Please remember, we were talking about those factories, and really the mu factory is the yellow line. So this is how the performance or the gauge, we'll bring on those gauges just now, of the mu factory is changing as the concentration of ethanol is increasing in the fermenter, and the red line will of course be the theta factory. So whenever you're looking at production, remember theta and mu are the main drivers, and as you ferment you will be making more ethanol as time progresses. You've seen those profiles, and yet that'll be affecting the way in which the two factories are producing. So just to quickly, and I don't want to spend too much time because we've got two more graphs to look at. So over here, if I use that, I've got a theta gauge over here, and I've got a mu gauge over here. So just have a look so that you understand what I'm doing with my little needle on my gauge. Right at time 0, I am operating both theta and mu at the maximum. Okay, so you can now see as the ethanol concentration increase, my theta value only, well, it decreases but not a lot. So you can see that, you know, I've got a slight decrease from this one to this one, but that's because of the slight drop in red. So it's only a slight drop, but for the product concentration it is a completely different drop. So what you have here in your little gauge is that theta is dropping to exactly 0. The needle drops to 0 at this point over here. Okay, so this is the driver for the whole fermentation, and you got to keep this in the back of your mind before you start having a look at the volume-based rates and the mass and the biomass-based rates. So let's get on. So this is now the RE, the mass, the biomass-based rate. Have a look at the units here at C-mole ethanol per C-mole X per hour. This is the graph directly from the notes that I've generated for you. I'm just going to make this one smaller and redraw it like before. Okay, and now we want to think what is happening, because the only difference between this graph and the previous graph is that we're now plotting ethanol concentration. So ethanol is now a byproduct of that mu and theta factory. So just think both factories are making byproduct ethanol, and we're not looking at how it changes over time, or how it changes with concentration, but how it changes over time. So this is the result from the integration that we got. We first got concentrations and then we back calculated it into rates. So what's happening over here? The ethanol is definitely dropping up to a point where it kind of stabilizes or almost stabilizes. So what's happening here, and this is where this emoji is very important. Right at the beginning, the microbes are doing this. Okay, they are very happy because there's no ethanol in there, and they are really pushing the ethanol production. Okay, and then as we get onto over here, we will see on this little red section over here, we effectively only have maintenance production. So the push of the ethanol production over here is really not up to standard. And this is, of course, all driven by the combination of the gauges. So I'll just bring on the gauges for this last section. So in this last section, we can put on the mu gauge and we can put on the theta gauge. And what we have is that mu is basically over here. At this point over here, mu dropped exactly to 0. So on this time over here, mu has now become 0. So that implies that this section over here is only a maintenance driven section. Okay, what happens to theta? Theta, as we have seen before, is still fairly high. It's still maybe not exactly at its maximum, but it is producing at a significant amount. It is slightly dropping, so you can see there is some inhibition in theta as we have defined in the function. So as we move from here to here, the needle will drop slightly. The mu needle will remain at 0. So remember, this little power plants are really the source of all production, because we're interested in rate of byproduct or ethanol production, which is a byproduct of energy production. And we can see that my energy production in this section over here is only driven by theta, while mu is 0. And that's really why the bug itself is kind of not very happy, because it's not pushing as much as it did initially when mu. So initially, and I'm just gonna, maybe I'm taking too much of your YouTube time, but right here at the start, remember we had it before, mu was producing at full capacity in combination with theta producing at full capacity, and that's why we had the little happy face over here, because really the production per cell, and RE is ethanol production per cell, was pretty high. So now we need to go on to the fermenter, because this graph was just looking at the cells themselves and what they were doing. So if we get onto the fermenter graph, get the following. So this is also straight from the notes. I have plotted those graphs for you. Interesting shape here, a lot of explanation to do. Let's just make it smaller. Okay, I'm just going to put it here. I'm just going to bring the previous graph on. I'll basically replace it over here, so that we have a reference as to the mass or the biomass based rates. Okay, so very first thing to note is that we have a volumetric rate here. So that implies that we are going to be using fermenter emojis. Okay, let's get them on the show. So initially over here it's low on this emoji at time 0, even though, if you remember correctly, even though the cells were producing at a very high rate, the fermenter is not pushing the ethanol. And that's really just because of the low cell concentration. Can you see the pale color over here? So this changes over time. And the main reason for this massive increase in rate is really related to the growth. There's more cells forming in the reactor over time. So what we get over here, where we have that turning point, is the real happy fermenter pushing the big ethanol weights. Okay, so your question now would be, why do we drop from year to year? So this little section over here is really this last section over here. So there is still a bit of growth. Maybe I can put the mu gauge on here. So if we have a look, and you can get all of this from your code, the mu gauge in this section over here won't be 0, but it will be fairly low. So I am talking about this section over here where mu will be fairly low. So what happens is we basically change from the fermenter that's full of biomass. So just have a look at these two emojis. Kind of over here, we still have a volumetric good push. Why do we have a volumetric good push? Because there's a lot of cells and my mu factory is still contributing. Remember, my theta factory is more or less running, not constant, but it's just slowly decreasing. Okay, and then from year to year, we lose all our mu. So effectively, the mu now gets to 0. So the mu gauge, as we get to this specific point, will now be at 0. So one of the factories has shut down. Okay, and now in this section over here, we are only driving on the coal or the glucose from maintenance, and really that's why, even though we got a lot of cells in the reactor, they are just producing according to the maintenance rate. So we can drag on the theta gauge for this section, and please note the theta might not be exactly at the maximum, but it's still pretty high. Okay, but this is the only factory running over here. So effectively in this zone, and we can bring on one of these now, we're going to really emojify this graph. In this section over here, I'm talking about this section, the bugs aren't pushing the ethanol. Why not? Because it's only operating on the theta factory. The mu factory in this section, that's over here, has shut down. Okay, and that's why the volumetric rate, even though you got a lot of cells, is much lower than what it was at the maximum when the theta was still contributing to, where the mu factory was still contributing to production. Okay, so note that the happiest cell, while we're putting a million emojis on, is over here. It remains kind of happy as it moves towards here. It won't be as happy as it was over here. And that's really the thing where we multiply with the catalyst concentration to get the volumetric rate. So I'm really hoping that you are getting the picture in terms of linking this graph with this graph. The numerical solvers are very handy. They really help us a lot. But it's all about understanding what the output is giving us. Okay, it's the integrated result from instantaneous rates. So we looked at how the concentrations in the fermenter changed, the response of the bugs, and then depending on the amount of bugs, that changed the response of the fermenters. Okay, so please distinguish between fermenter productivity or fermenter push and microbial push, because there's a balance between the two, and I want you to see it in this graph. It's a nice way to see how the balance actually goes through a maximum. Okay, that's it for now. I hope this gives some more clarity on that ethanol example.